Good day, everyone, and thanks for joining today's webinar, Instrumenting the Hybrid Cloud. I'm the Chief Technology Officer at Civision. I'm Rob Doucette, and I'm joined by John Joyner, who's the Director of Product Development at ClearPoint. He's also been awarded the MVP Award from Microsoft 8 years in a row. He's co-authored some of the best books that are available in the System Center space, and he's also an avid blogger. John will set up the presentation describing some of the challenges with managing the hybrid cloud environment. About midway through the presentation, I'll do a small demonstration on how Civision solutions can help with these situations and then provide some improvements over managing distributed applications. And then we'll hand it back to John and he'll wrap up the presentation. So without further ado, take it away, John.
Thank you very much. It's a great introduction, Rob. It's been a pleasure working with you so far. Civision is a wonderful company, good people, good product. And so is System Center. Microsoft has a great product that we're going to showcase today in a fairly new way in terms of deploying System Center in a hybrid cloud environment. So when we talk about the hybrid cloud specifically and the challenge to manage and monitor it, by definition, the word hybrid means that there's multiple components to our cloud, multiple pieces and parts, and that's what makes it hybrid. And the ability to watch two or more distributed things together in the same time, in the same context, presents challenges, particularly when you're trying to manage in a multiple cloud provider, a hybrid cloud environment that involves multiple public cloud providers. And we're going to show a very nice way to tie it all together with System Center. A question that emerges often when I start talking about managing and monitoring the hybrid cloud, and people ask, what about the what about the products? What about the portal? What about the AWS portal or the Azure portal? That both of those public cloud providers have attractive, meaningful displays that let you observe the health of your Amazon or Azure resources. But frankly, unless you're 100% using the just one public cloud provider and you're mainly just using one piece of their stack, it's going to be very difficult, if not impossible, to assess the health of your whole application if it depends on multiple components. There's the matter of screen real estate, and the matter of how many screens that you can watch at once. So, even in the simple model today that we're going to build out, we're going to show a company that has some Amazon EC2 instances, some Azure virtual machines, and some dependency on Azure storage. And so just if you weren't seeking a holistic solution to manage your hybrid cloud, just to monitor those three things I described would require at least 3 monitors side by side, or 3 tabs on your browser that you scroll between to assess the Azure storage health, the Azure virtual machine health, the Amazon EC2 instance health. And so, what if we had that at scale? What if we had 30 instead of 3 things to watch? We need a solution, and that's what we're going to talk about today. We're going to talk about building the big picture, the holistic viewpoint that synthesizes the health of your application wherever the components may reside. So I've got a couple of key points to get across in this presentation, and they involve 2 concepts. One is the concept of deploying instruments, and the second is displaying the results of that instrumentation in a meaningful, useful way. So the overall themes in this seminar are, here's the Microsoft System Center platform. Here's how you adapt it to monitor Azure and Amazon and on-premise resources together. And then once you've got the framework there, we're going to cover all the types of sensors and instruments that you can place as needed. What is the secret sauce going to be in your environment in terms of what to monitor and what to watch? And then we're going to show how to put those sensors together into diagrammatic, picture-based displays. It's well known that the human mind can process visual instrumentation, rather visual information. The human mind can process charts, colors, line graphs. Our brain is wired to interpret this information hundreds, even thousands of times faster than reading text or reading some numbers and then performing a calculation on them, and then in our own mind doing some analysis to make sense of the words or the numbers. Rather, let's take advantage of the human mind's ability to look at something and then rapidly make sense of it. And so that's basically we're setting up two kinds of instrumentation automation, and then we're setting it up for human decision making, to make that human decision making as fast as possible. To deploy that infrastructure and place the management packs and tools out there to do this work, there's 4 high-level steps. And the first is to deploy Operations Manager. You may or may not already have Operations Manager in your environment. In a moment on a slide, we're going to cover some tips on where to ideally locate your Operations Manager management group, some options. And if you haven't cited one yet, or if you want to consider the most useful, most resilient place to site your management infrastructure. So we're going to deploy Operations Manager in a way that's suitable for a hybrid cloud environment, and we're going to deploy the management packs from our cloud providers to monitor our infrastructure in those clouds. We're going to cover in detail a concept in Operations Manager called the distributed application, and how that becomes our vehicle to make our diagrams. We're going to create basic diagrams, and then we're going to extend those diagrams by considering dependencies, internal and external, that our cloud applications may have. So we're going to have some real-world type things we're going to add. We're going to add a web feed into an online business application. We're going to add a virtual network connection to on-premises where domain controllers reside, where authentication has to happen for the cloud app to work. So we're going to flesh out our basic distributed application that has our public cloud elements in it, with additional external and internal elements that those cloud applications depend on to create the big picture. And then the last thing that we'll cover in the presentation today is how we can observe diagrammatically in the form of a picture or a chart, how we can display and consume this information in the way that's going to be the most meaningful to us as rapidly as possible by leveraging that human power visual processing. So again, I mentioned that we would talk a little bit about deploying Operations Manager in the context of hybrid cloud management. What are some things that you need to think of particularly? So the first bullet here on this slide, referring to SCUM as part of a system center strategy. This short discussion will be for listeners that are not yet fully vested in the System Center solution, in that you're using many of the System Center products throughout your data center to help you get your work done. So if you're not familiar with this concept, Microsoft actually about 3 years ago changed the licensing model for the System Center 2012 products. Basically, if you're licensed for one, you're licensed for all, and you're not licensed on how many System Center servers or even how many SQL Server standard databases those System Center servers are using to do your management job. Basically, all that is now free from the Microsoft licensing perspective, and you pay for System Center from the machines that are managed. So you buy a management license for a particular physical machine or for a virtualization host, and then the machines that are running on that host. And once you've purchased a management license, you are allowed to use all of the System Center products as you see fit, those being Operations Manager that we're talking today about monitoring, Config Manager for patching, Data Protection Manager for backup, System Center Virtual Machine Manager for hypervisor management and replica availability. So that the list of things you can do with the System Center suite is extensive, and you may already be using System Center for example, the configuration management, and you are thereby at very low cost or almost no cost able to add the monitoring piece using the System Center Operations Manager product that's part of the lease. So that's, if you're already vested in System Center, then the tools to deploy the infrastructure that we're going to cover today, the monitoring infrastructure, are at your disposal with little additional overhead. Now, the second bullet refers to a discussion I want to have on the System Center Gateway component and the certificate authentication mechanism in System Center Operations Manager. Particularly in the hybrid cloud management space, you are going to need to become familiar with the SCOM Gateway component and the certificate authentication method of using Operations Manager. These are very well known and well understood, well documented System Center components, but I just want to call out their importance in this model. The System Center Gateway, as we're going to see in a slide in just a moment, you're going to locate a gateway, at least one gateway, in each of your hybrid cloud network environments. So if you have a virtual network in Amazon, you'll have a SCOM gateway there. If you have a virtual network in Azure, you'll have a SCOM gateway there, and you may have SCOM gateways at one or more private clouds or partner clouds or other on-premise networks. And in each of these networks having a SCOM gateway present, that gateway assumes the duty of communicating with all of the computers and network devices in that cloud segment on behalf of your overall organization. So you'll cite gateways as your landing head, as your beachhead, as the place from which you're going to do launching your other agents, which will be probing your applications. So you have the small number of gateways managing what can be a very large number of computers and network devices. And then tying these gateways together back with your management cloud will be certificates, Microsoft certificates, digital computer machine certificates that are issued to the SCOM gateway and the SCOM management servers that allow them to communicate across network boundaries without requiring Active Directory domain trust. So it's a very lightweight and high security way of achieving authentication, which is independent of Active Directory. It works across Active Directories, works in work groups, lets you manage Linux machines, network devices, really without limitation. You just need to appreciate that you will need to have a certificate authority deployed and use the certificate-based method of deploying your SCOM gateways. This is the picture that I talked about that hopefully ties it together a bit. In the lower right-hand corner of the screen, you can see a representation of an operations manager management group. So this starts with one all-in-one machine, a fairly powerful machine, let's say 16 gigabytes of RAM and 4 cores. A machine like that could manage 100 or more remote servers in different locations. As you need to manage more than about 100 servers, that management group scales from a single server to 2 servers. That would be a SQL server and the management server. We split off the database function from the all-in-one. And in a 2-server model, several hundred up to perhaps 500 remote computers could be supported at full performance. And as we scale beyond that, we add additional management servers. Perhaps we split off the data warehouse from the Operations Manager database, further distributing our SQL load, adding more management servers. And as you add more management servers and make your SQL backend more scalable, many thousands of machines can be managed from a single management group. In this drawing, we've got 3 remote clouds or 3 networks that we're monitoring. We have a gateway in Azure, monitoring Azure virtual machines in that virtual network. We have at the bottom of the screen in the center, we have a gateway in an Azure EC2 virtual private cloud with monitoring virtual machine EC2 instances. And in the upper right-hand corner, we have an on-premises network. We have a gateway there that's communicating outbound through the corporate firewall to the Operations Manager location. And I mentioned that I would talk about a place that you might want to site or locate your Operations Manager installation. Here at ClearPoint, we refer to this as the management cloud. The management cloud is not necessarily your main data center or your DR data center. Perhaps it's a dedicated small network in a third location, which you're highly comfortable with the availability and access to. You want to give careful consideration to where you locate your management group, the computers associated with it. Because, for example, if you locate it on premise in your primary data center and all the monitoring is outbound from there, should you have a disruptance, a loss of connection to your main data center, you're kind of blind. You're not able to manage your other resources. So you might want to consider locating your management cloud in a neutral area, or even a public cloud resource that you dedicate just for this function, to be that high ground from which all of your other hybrid cloud environments are managed from. So we may refer back to this slide a few times. We're going to dive into a demo environment in a moment. I'm going to show you two management packs that we import and how we configure and use those. There's a management pack from Microsoft, which is called the Azure Fabric Management Pack, and that will attach to our Azure subscription and let us monitor virtual machines, cloud services, and Azure storage accounts. Then we're also going to look at the Amazon AWS Management Pack. When you import that, you're able to discover all these listed Amazon features such as CloudFormation stacks, Elastic Beanstalk applications, and Elastic Load Balancers, and surface all these in Operations Manager as well. So once, this going back to our objectives in the session, these are how we're going to locate our instruments within our public clouds, is by importing these management packs and discovering these public cloud components that we will assemble into a distributed application that models our line of business work. Here's an example of that we're going to see live in a moment. This is a distributed application view of an Azure website. This is an Azure website which consists of two highly available web roles behind essentially a load balanced solution in Azure. This is the default high availability website application for Azure. And this distributed application, this diagram view, is an example of a diagram view that is automatically generated by one of the partner management packs. So this particular distributed application diagram was automatically created, and we'll take a look at it. And notice I'm highlighting in the red arrow. There's a task there, Windows Azure role task, change number of role instances. So remember that not only are you able to monitor, your cloud resources, but as the management pack providers have included them, you're also able to operate with and interact with and even perform basic maintenance and administration tasks against the Azure and the Amazon public clouds without having to log into their respective portals. You're able to do it all within Operations Manager by virtue of the management pack task feature, which I'm going to show you. So this is our prompt to go into our first demo. And so I've immediately taken us into a demo environment. We are looking at the administration space of a System Center Operations Manager 2012 management group, which has had the Azure Management Pack imported. I've got just two quick links here to show. Here is an article that I wrote at the System Center wiki on the Azure Management Pack. So scrolling down just a little bit past the introduction, here is the link. You can see it in the center of the screen, Management Pack installation. So there is the link to download the Management Pack. It's easy to locate at Microsoft. Just search on the Azure Fabric Management Pack download. And I would encourage you to read this wiki article, which should also be fairly easy to locate at Microsoft TechNet. And that will walk you through the Azure Management Pack download and configuration. The other link that I have here in my web browser, this is the Amazon add-in for System Center. This is their Management Pack. You can see they have links to both the older SCOM 2007 version and the current SCOM 2012 release. And so, of course, we'll be looking at the 2012 release that we've imported. So downloading these management packs and importing them into your Operations Manager management group, the first thing that we'll notice is that this Windows Azure element is added to our administration space, and we have a spot where we would physically upload a certificate file with password to access our subscription. So I'm going to contrast this in a moment with the new Microsoft Management Pack for Azure, which uses a different mechanism, a simpler mechanism to connect. But this is the current Azure Management Pack release that you'll specify your subscription number, and then you'll physically upload the certificate file protected by password. So you would export as a PFX file one of your effective management certificates. You can find them in your Azure portal under the settings management certificates. They're listed by thumbprint to help you locate the one of the management certificates that's in use for your subscription. And then you, having provided that certificate, will have somewhere an authoritative source of that certificate that you can export with a private key, and you'll export that file as a PFX with private key and import it into your operations management installation, and that's how Operations Manager will be able to access your subscription and provide monitoring for it. Once you've imported the management packs, and in the case of the Azure Management Pack, added your subscription, the next place that you configure these management packs is in the authoring space. Looking at the Windows Azure monitoring, you can see this is the next step that I performed. Again, this is all covered in the wiki article, that after adding the subscription, we then, these are the actual storage accounts of virtual machines and cloud services that Operations Managers discovered in Azure after you gave it the credentials. So the next step in configuring the Azure Management Pack is just selecting which of your resources you want monitored. In the case of the Amazon Management Pack, it's a different approach. When we look at the properties of this Amazon Management Pack that we've configured, the main thing you need to do is accurately configure the credentials to your Amazon environment. So you will have a shared secret and a user ID associated with your EC2 subscription, and those two pieces of data, that secret access key and the password, you will provide those when you set up the Amazon credential for your management pack. And when you do that, the default behavior of the Amazon Management Pack is to discover everything, to begin monitoring everything it discovers. It will create a self-contained management pack in view for all of the Amazon resources that it finds at that subscription. So the approach of the Amazon is everything. The approach of the Azure is more granular in what you're going to monitor. Now, I mentioned that the new management pack from Microsoft uses a different approach. This is a pre-release version of the management pack that I'm showing you. And so this is not yet available for download, but I wanted to share it. Microsoft has shared it with me so that I can let people know where Microsoft is going and is making progress in their management pack development. So now on the pre-release, the new version, when I go to the Azure Management Pack setup and I look to edit the subscription, I'm going to see a different view. Rather than prompting me for the certificate, it's prompting me for the username and password. A username and password that I've created in Azure in my Azure Active Directory account that is authorized as a co-administrator for my Azure subscription. So rather than require you to locate that certificate, now they've made it a little more lightweight and easier process to use Azure AD and a username password rather than a certificate mechanism to get in and select your certificate, rather to get in and select the subscription that you want to manage. Another new feature, again, looking at the pre-release version of the management pack. Looking at the properties of the monitoring of the authoring wizard in the new management pack, Microsoft has gotten a lot more granular with the Azure services that are discovered, and then allowing you to select which performance counters to collect from those resources. So again, I'm entering the password rather than providing the certificate. So now using the Azure AD to go in to look at my subscription, the management pack has discovered all of these different resources For example, there are 16 domain names. There are 12 virtual machines. There is 1 virtual network. There are 4 reserved IPs. These are the instance counts that the management pack has discovered in my Azure subscription. So a lot more granularity in terms of which components I'm going to want to monitor. I can obviously select them all or some. Microsoft is also going very granular with the performance counters. Again, this is the new pre-release version of the management pack. Once I have identified my Azure machines, or rather my Azure resources, now I can actually go very granular on what data to collect. For example, if I didn't need to collect network data on these particular machines, I could deselect collecting that, reduce my management footprint. This can, just minimizing what you're capturing at the performance level can over time result in a cost savings, because some of these performance counters consume Azure storage for temporary storage area, and at scale and over time it could have a financial impact. So Microsoft is letting you have really complete control over what you monitor to make sure you monitor what's important to you. So moving back to the production version of the management pack. After the management pack has discovered your items, I mentioned that there's, for example, distributed applications that are automatically created. So here is a diagram view. I'm in the distributed applications. This view was automatically created for me by the management pack upon discovering the Azure resource. When I click on go to diagram view, it will be able to walk me through to the This is the one I was looking. Yeah, here we go. This is a diagram view of the distributed application. So this is the same slide that we saw. I'm focusing on the role that has the 2 instances, and here's where I get the task, change number of role instance. So this is what it actually looks like. Let's say that I wanted to increase from 2 to 3 instances of this store, this online web store. Let's say I'm going to do maintenance, rolling maintenance. I need to have 3 nodes instead of 2 during that period to have no loss of service to my customers. So I'm just going to temporarily bump up my instance count. If I were to click OK, or rather run right here, it would actually reach out into my Azure subscription and spin up a 3rd instance of this website. So that's a really powerful example of how you can interact with your services. Likewise, looking at the Amazon services, if I go and list my EC2 instances, some of them are stopped, I think, right now. So here's an example of being able to interact with my Amazon instance if I were to click Start over here. So again, this is a remote task that is going to go into my EC2 subscription if I were to click Run right now, and it would actually start that virtual machine in my EC2 instance without me having, again, to have access to or rights to or even understanding of how to get into the AWS portal and find the right spot to start a stopped instance. To my operators, I've extended them the ability to do that through the management packs. So now we are going to focus on the distributed application model. I'm going to show how we created a distributed application, and then Rob is going to let you know how Civision meets this requirement in a different and frankly better, easier way. But to use the built-in distributed application features, you go to the authoring console. There's a distributed applications area. And if I open this existing distributed application, we can begin to see how the environment works. We can see that when I open this, it's always going to open in a default fashion. And this is one of the drawbacks of the distributed application environment using the native tools, is that your initial models are going to often open in a fairly complicated or difficult to understand layout, because the positions of the components within this graphical environment are not static. They essentially re-render automatically each time you open it. So although logically it's always accurate to the human eye, there is a big downside in the way that Microsoft distributed applications in System Center initially display themselves. So you can see the time it just took me to arrange those components into a more understandable layout. So we're going to show you a couple of ways to avoid having to do that each time, but this lets you see the construction of what is a fairly complicated distributed application right now. But it starts, for example, in this case, with these two components, Azure VM, Cloud Service N5 and N4. So these represent two Azure virtual machines, each of which needs to be running for my application to be working. And these two Azure virtual machines share an Azure storage dependency. So in other words, the virtual hard drives of both of these Azure virtual machines are contained in this Azure storage container. So when I start out my application simple, there is a white paper at Civision that walks through these steps. The first thing that we do is we make a simple distributed application using this authoring environment where we graphically indicate these two machines share a dependency on the same Azure storage container. So that's how we begin. And just from having that information, we are able, at a glance, should something go wrong, we can tell if it's because both machines are coincidentally down, but the storage is up. Both machines are down because the storage is down. One machine is healthy, the other and its storage are healthy. So there's 4 or 5 possible combinations of health and reason for health that we can quickly determine just from that having just those components diagrammed and with accurate status behind them. Because when we view this status in a live diagram in Operations Manager, there'll be a green checkbox or a red X or another symbol to let us know the health of that. So this is the way that they're arranged and how they depend on another are the clues to help us solve something when something goes wrong. Then we add to this distributed application. Now in the right-hand corner, I'm taking and moving around slightly 2 Amazon instances, 2 Amazon EC2 computer instances, in this scenario, both of which need to be running for our application. In our evolution of our distributed application, if you can ignore the 3 bubbles in the lower portion of the display and just look at what looks like about 6 in the upper part of the display, we now have a distributed application that has 2 machines in Azure and 2 machines in Amazon, all 4 of which need to be running for our application to be fully healthy. Plus, we have added intelligence at this point of knowing that 2 of the machines depend on the same Azure storage container. Now, these other components at the bottom of the diagram, we'll explain those in the final demo when we come back. So this distributed application, which I've just set up, was fairly labor intensive and required a bit of knowledge for me to accurately create those components and arrows. Robert, did you want to take this moment and show how Civision has a shortcut to making these distributed applications?
That'd be perfect, John. You can just pass the presentation controls over. And you can just give me a verbal, John, when you see my screen with the live software console. Perfect. So I just wanted to take a few minutes. John's talked about some of the challenges with using distributed applications, and we've provided a way with the Live Maps authoring console to simplify some of that. So I'm going to jump into creating a service, giving it a name. And what we've done is we've broken out every distributed application or service, as we'll refer to them within Live Maps, into 3 perspectives, breaking into end user, application, and infrastructure. As oftentimes just seeing whether a service or application is healthy or unhealthy is not enough. We need to understand, is it impacting end users? Is it an infrastructure problem that's maybe associated to some redundant hardware that's okay for now? The actual service is still healthy, but we can look at the infrastructure part separately. So we have a simplified wizard that will walk you through each of those 3 perspectives. And we've automatically categorized some of the object types that SCOM exposes to help you find the right thing. So for example, for end user facing things, we typically want perspectives or synthetic transactions. So they're available by default in the selection here. And I can see things like agent watchers, transactions that I've set up and so on. Of course, at any time, if you need to get to something custom, we do expose the custom object picker. So there's no limitation here. It's really just to help you get to the objects that make sense. So I can, for the sake of this example, just pick one. And then we get to the application, same idea. So we have here components are already filtered for databases, websites, SQL roles, that type of thing. So I can quickly find what I'm looking for. And last but not least is infrastructure. And you'll notice here on the right that we've already automatically selected the Windows computer for the service. And that's done based on what was selected in the previous steps. So if I pick some databases or websites from a particular computer or SQL server, we'll automatically add the Windows computer such that if there's something impacting the Windows computer at a more core health thing like disk health or network health, we'll see that impacted as well, because that will have an impact on the service. And then, so if I were to hit finish, we would save the MP and store it in the SCOM. That takes a minute, so there's no sense me showing you a loading screen for a minute here. I just wanted to point out a few other areas that we have here. So you may be wondering, well, I've already created a number of distributed applications, or perhaps you're reliant on some of the Microsoft management packs like Exchange that automatically generates a distributed application that does provide some value. Or even some of the third-party vendors out there that create distributed applications. So we've done a lot of work with Blue Stripe, for example, and they have a discovery component that automatically creates distributed applications and then keeps them up to date as the environment changes. Well, we have the ability to import those DAs automatically and keep them up to date. So we're able to periodically check the state of those DAs. So if the Exchange MP, for example, has updated that MP, the live maps piece will detect that, we'll import it into the service so that the representation from the live map side is also always up to date. And so one of the other benefits of this, as John mentioned, sometimes the output that's with the DA, it can be a bit difficult. So one of the benefits of walking through the wizard here to create a service using live maps is the output. So what I've transitioned to here is within the Operations Manager console, we have what we call our All Services Overview dashboard. So as you walk through that wizard, create some services, this dashboard will automatically be created for you. You don't have to do anything manual here, and you'll see the health of your services as well as the health of each of those perspectives that I mentioned earlier. So I can quickly see, I have a hybrid cloud service here. End users are being impacted, so that's something that gets bubbled up to the very top, so that's the highest impact and something that should be looked at first. I can drill into each of these services and get more detail about the service. So this is going to show me broken down by perspective again, what is the status of each of these perspectives? One of them, I created the service fairly recently, so one of them is still being calculated by SCOM. But I can see here that one of the Windows computers associated with this is unhealthy. And from here, I could dive into the native SCOM functions, whether that's a health explorer or the properties, things like that. As well, you notice in the bottom a detailed pane for service level agreements. So one of the other benefits of using live maps to model your services is we automatically create service level agreements for the service as well as every perspective. And here I can quickly get information as to the health of my service with respect to service level agreements. So I can see what was the goal that I defined, how much downtime have I had so far, how much downtime am I allowed for this reporting period. In this case, I'm showing 1 month. And I can really browse through here at the different perspectives to see how my service has been performing. And last, I just wanted to quickly show, once the service is created, so this is my hybrid cloud service, I mentioned the SLA agreements that are created. We've made it very easy for you to go back here and redefine the goals. We provide the defaults of 99%, but then you can go here and change them as you wish, as well as the reporting period. We also provide some simplified role-based access, so it's very easy to grant access to these dashboards or even the perspective. So for instance, if you want your manager to see a high-level dashboard, like this All Services Overview dashboard that I showed you, but you don't want them to have the ability to start drilling into the details, we can easily turn that on and off using this screen here based on the Operations Manager user roles. As well, we can create consolidated notifications. So instead of getting 50 or 100 notifications that all relate to your hybrid cloud, you can consolidate those into a single notification that will alert you that there's an issue with your hybrid cloud with the end user perspective. And then from there, you can drill into the underlying alerts that are associated with that higher level state change. And last but not least, we have the ability to relate items to other services. So, for instance, my hybrid cloud depends on some other services that I've already created that model, my AWS instances, my Azure subscription, and some Hyper-V on-prem resources that I have. So it's very important to be able to see how this is related to other services. The simple example I always use is if you're monitoring Exchange, Exchange is highly dependent on AD, and AD is highly dependent on DNS. And if DNS is unhealthy, there's no point going in circles trying to figure out why Exchange is unhealthy. We'll immediately notify you by bubbling up DNS at the top and tell you this is where you need to start because this is why your other services are unhealthy. So it really simplifies the troubleshooting and impact triage process. And I should point out, we have all these great service views with high-level dashboards, but we still have the ability to get into more graphical, simplified diagrams and lists. So I have a System Center dashboard here that's a very simple graphical representation of the System Center components in this little environment here. So I can create a free-form diagram, a very simple example here, but I can also dive into more elaborate examples where I've selected my own background and provided an overview of the health of the Heathrow Airport, for example. And one of the areas where DAs, again, are lacking is the ability to have nested views. So in this example, I'm able to drill into various levels of detail here based on what I'm looking at. So if I need to dive into a specific terminal, I can do that here and get more information about that terminal. Something that would be very difficult to do with DA. So I can get into different levels of detail here and provide some nice drill down behavior really quickly. So hopefully that shows you some ways that we can help you with some simplified DA creation and even leveraging the DAs that you've already created. Pass this back to you, John.
I think you need to make me a presenter again.
It's coming.
So let me set up the last demo, which is going to be adding those additional components that add the fidelity to our app, and then showing you how that looks both in the default distributed application diagram view and very tidied up and very clean using a Civision product called Live Maps. So we created our core distributed application, as you recall, that included Amazon and Azure virtual machine resources as well as Azure storage resource. So we had 5 monitored components that were the core public cloud pieces that we needed to keep an eye on. So now we want to make that distributed application even more valuable. We want to make it more actionable by adding more sensors to it as needed to account for what could go wrong with that application. So this is a list just to get you thinking of some of the internal and external dependencies that may exist. They're almost by definition is no hybrid cloud application that stands alone. There are often extensive interoperability needs between cloud components, between partners and public web services, everything needing to work together. So we can adapt our distributed application to account for that. So think of your DNS. DNS is a big root cause quite often. So accounting for how DNS is being delivered to support your application is a consideration. We have all the physical pieces that come together to deliver your app, your data center switching and data center fabric routers and other load balancers. We can put those into the mix because they certainly can be a root cause when something goes wrong, something at the physical layer. We can have Active Directory or other security identity provider dependencies. We can depend on particular ISP circuits or interconnects between our data centers for things to work. We may have external databases or external data sources, such as external RSS feeds that are consumed by our application. So if our application can stop when the external feed stops, let's monitor the external feed, put that into our distributed application as well. And the last bullet there is we have to remember that public cloud services have this other element to manage, which is the subscription health itself. Is it not been cut off due to error, non-payment of subscription, or for whatever reason? It is something that can fail, and so we need to watch that as well. Of course, using the Amazon and the Azure Fabric management packs from System Center is almost a guarantee to watch that, because both management packs critically dependent on monitoring of the subscription health to do their work. So if there was something to go wrong with the subscription, you get feedback right away. These are a couple of questions you can ask yourself. If everything in my distributed application were green, so in other words, in our simple example so far, if all 4 machines are running healthy in their 2 respective clouds, but the users still report that they can't buy my product, they still can't post their time, they still can't make that vendor report, they still can't do their work, what else could it be? And so we ask those questions, and we add fidelity to our management pack by adding more elements. If something in my distributed application were unhealthy, then what would be the next thing I would check? And if you are already using System Center to monitor those additional things, put them in the distributed application. If 2 machines are down, and that suggests to you that they, because they share a common switch, that the common switch could be the next culprit, monitor that switch with Operations Manager Network Monitoring and add the switch to your distributed application as a component. And we're going to look at how SCOM displays diagrams by default. We're going to discuss that Microsoft has a solution using Visio and SharePoint, and that Civision has a wonderful solution that we have deployed as well, which will be the last thing that I show you. Returning to our demo environment, here's a really nice view, a live view of the Amazon EBS volume performance of our EC2 instances. So this is wonderful information on the performance of the Amazon storage system as it supports our application, and this information is coming into Operations Manager, we might say out of band. I don't have agents on the Amazon EC2 machines themselves. This information is coming from the Amazon Fabric right into System Center Operations Manager for you to consume from that. Operations Manager is literally being your single pane of glass across public cloud providers when it comes to the performance. So returning now to our authoring space, looking again at that distributed application. So we talked about adding fidelity. So let me quickly discuss these other elements that have been added to the distributed application drawing. We have on-premise domain controllers that are required for our the piece of the solution that's running in Azure needs to communicate with those on-premise domain controllers. And so to get that done, we have a dependency on the domain controllers themselves. We're monitoring both of those Active Directory domain computers with Operations Manager, so we can put their status, live status, in this diagram. And these on-premise domain controllers need to communicate through the Azure VPN into the Azure Virtual Network. And so since we've discovered that hardware device, that Cisco router that's doing the IPsec tunnel into Azure for us, we're monitoring that router. So since that's a point of failure in the authentication path for our application, we can include that in our drawing. So now we've added a lot more completeness to the side of our application running in Azure in terms of the pieces it needs to run to be healthy. On the right-hand side of the drawing, we added another real-world element to our Amazon side of the equation. And in this example, we are showing that the Amazon piece of our distributed application is consuming data from an RSS feed. So there's a public website or a website available over the internet, perhaps with authentication, and the app in Amazon is pulling data from that third-party server. So in this case, we deployed an Operations Manager synthetic transaction, a simulated web login session to verify that that RSS feed is healthy and timely. And so we're monitoring that as well. And if that, this is an example of the Amazon machines could be running, but the customer service app isn't running because the customer service app needs this third-party RSS feed to be running, and we incorporate that idea into our application. So now that we've created a very meaningful, thorough distributed application that captures all of our data, now let's see what is the visual product look like that we've made. And the default Microsoft product is going to be a distributed application view, much like this. It's going to let me know that this is going to be a complicated diagram, but I know that. So I've actually this is the that was the Civision Live Maps diagram view, and I wanted to show you the default view from the Microsoft. Here we go. So we can see that while the diagram, it opens with just the unhealthy components highlighted, I have to do a lot of manipulation of this drawing, manually opening things, continuing to move around and navigate within my drawing. And if I wanted to see the context of the unhealthy with the context of what is still healthy, goodness, look how the diagram became quickly difficult to follow. And in order to see which healthy components are depending on the unhealthy components, I have to go through a process of physically dragging the objects around so that I can notice where the blue dependency lines move. And this is really not a satisfactory solution when you're in a hurry and you're trying to figure out what is the root cause. So this is a weakness of the Microsoft built-in distributed application diagramming feature, is that there's somewhat of a randomness to how the display actually appears each time you generate it. So to get around that, to make the diagramming more useful, to get the most use out of these valuable diagrams, often we need to seek a way to display a static display rather than a randomly generated topology. So Microsoft provides a way using their tools, using the Visio and the SharePoint product. So using the professional version of the Visio product, you can connect into your management group and create drawings which remain static each time you open them. You will get the same visual display. And what I'm going to show you now is the solution that Civision makes for diagramming. And I've just called up a diagram view of the same distributed application that I was showing you before, only this one has been rendered in the Live Maps products from Civision. And you can see we have the two in the upper left corner. We have the two healthy machines in Azure that share a common storage account. And we have the two on-premise domain controllers, which are using the Azure VPN router as their access into the Azure private cloud. So we have and you can see the green check boxes. Those are live status indicators from the Azure Fabric Management Pack. On the right-hand side in the upper corner, we can see the two Amazon EC2 instances, one of which is down. And we can see the concept of that external RSS feed that the Amazon machines depend on, and we can see that that is a healthy feed. So this diagram is always going to open in a static and consistent manner and displays, I think, the best of System Center, the best of the Amazon and the Azure management packs, and the best of a partner solution, in this case, the Live Maps from Civision, that together allow you to confidently manage your hybrid cloud and achieve that single source of truth that is going to provide accurate and fast troubleshooting for you. So that ends our plan material. I'll turn it back to you for final comment, and if there's any questions in suspense there, Rob.
Great. Thank you very much, John. We do have one question. Ari has been waiting patiently for a question he asked earlier, which was in reference to your gateway slide. And he asked if the gateway is in the pull or the push config.
Well, that's a good question, Ari. It's in the, I guess, it would be push out, always using the outbound connection. So let me go back to that slide for you. In this model, for example, the Azure gateway is initiating an outbound connection. The on-premises gateway, an outbound connection. The Amazon gateway, an outbound connection. So in this scenario, the management server on the internet is listening to 3 incoming connections. That's the normal mode of operation, and that is the the least impacting because the customer generally doesn't have to prepare anything in their environment in terms of firewall. They only need to allow TCP 5723 outbound. You mentioned, is it inbound? And that's an insightful question that Ari, that shows you're letting everybody be aware that gateways have a alternative mode of operation, which is an inbound. And as long as you can establish outbound connection one time to establish the connection, if you install the gateway with this particular option, subsequent connections from the server to the gateway are inbound. And so the management server flips that and begins going in the outbound direction of the gateway. And that would be useful in certain special circumstances, but normally we use the default method of outbound.
Great. Hope that answers your question, Ari. We'll hang tight for another minute or two if anybody else has any other questions. And John's putting it back on the contact information slide here, so you can follow up with either Civision or ClearPoint. Our marketing team will make the slides and presentation available afterwards on demand, so stay tuned for that. And otherwise, I don't see any other questions rolling in, so I think we can wrap it up, John. Again, thanks very much for the detailed information and great presentation.
Thank you. It was fun, Rob, and we'll be repeating this next week at a different time slot, and I'll see you then.
Perfect. Thanks, John.